Alright folks, final video for 11.1 nodes here. Alright, so we're going to jump right into this final example. It's sometimes said that older people are overrepresented on juries. The table gives info about people on grand juries in Alameda County, California. Does it appear that these jurors were selected at random from the adult population of Alameda County? So, we have our age categories. We have, it says countrywide, it should say countywide. Countywide, here are the percentages, and then the number of grand jurors that are found on each. So what are each of the expected counts? Well, if I have 42%, I would take 0.42 and times it by 66. Oops, that broke my calculator. 0.42 times 66. Alright, and that gets me an expected value of 27.72 jurors that age. 0.23, 23% times 66 gets me 15.18. 66 times 0.16 gets me 10.56. And 66 times 0.19 gets me 12.54. So in theory, these should also add up to 66, but the important thing is that all of these are over 5 people. Okay. Alright, so let's go ahead, and now that I filled out this little table they provided me, let's go through our state, plan, do, conclude. So let's begin with our state. Dang, I need the same pen as before. Okay. So we are going to start by stating. Alright, so we need to state what is our sigma value. I'm going to be a little less specific here because we just did one. So sigma is 0.05. Let's state our null and alternative hypotheses in words. So the null hypothesis would be that there is no difference there we go, between the observed and expected values, expected numbers of jurors in each of the age categories. Jurors in each. And the null hypothesis would be that there is a difference in the observed, there we go, and expected number of jurors in each age category. Okay. Alright, and we're going to call that good for state. So, our plan we will perform a chi-squared goodness of fit test if conditions met. So we're gonna run through our conditions, and I'm gonna kind of run through them over here and keep it short. So the first one we would want to do is a random sample. Even though it doesn't say that they're oh, it actually does. These jurors were selected at random. Oh, does it appear that the jurors were selected at random? So the null hypothesis is that they are selecting them at random, right? So we are assuming they were, I should say jurors were, sorry, to be more specific.
What did you say in your email to your parents?
Alright, next we are going to be checking our large sample size, and that would be that all of our expected counts were at least 5. So I'm going to go ahead and just write that up here, a large sample. Now I do want to note, folks, really when you plan this out, you have to do one of two things. You must either list all of your expected counts and establish that all of them are over 5, and the minimum you could do is say, my minimum expected count would be in the 51 to 60 category is 10.56, which is greater than 5. Okay, so you either have to list all of them and say, okay, they're greater than 5, or you have to at least specify that your lowest one is greater than 5 and say that it's the lowest one. Okay, very important. All right, let's see, what's the last thing we gotta do is check if it's independent. We could assume that the jurors are selected independently. Can we assume that? Oh, sure, yeah, we can assume that the number of jurors is less than, all of the jurors ever selected in this county. So, so large sample, and then the last one I'm going to check here is independent. So everyone is selected for jury duty. Independently. Alright, and honestly, clearly they're going to be selected independently of one another. I feel very comfortable just stopping there and calling it good. Okay. Sorry, I'm trying to stay within my boundaries here. So next we're going to do, alright, so chi-squared. My chi's are so ugly, guys, sorry. Alright, so we want to write what we're actually doing. It's the observed minus the expected. Good, making sure I'm still on the screen for y'all. Squared. All over the expected squared. Nope, just expected. Okay. So this one, so short, I'm just going to go ahead and actually write it all out. So my number is 5 minus 27.72, sorry, 72 squared, all over 27.72, plus 9 minus 15.18 squared, over 15.18, plus 19 minus 10.56 squared, over 10.56, plus 33 minus 12.54 squared, over 12.54. Whew. And what does this equal? This is a drop from my handy dandy calculator. Okay. Sorry folks, this might take me a second. You guys are welcome to be typing this in at the same time. All right, and when I did this, I got 61.27. So hopefully that matches what you guys got. Okay, so the next thing I'm going to do is note that my degrees of freedom, my number of categories is 1, 2, 3, 4, so 4 minus 1 equals 3. So I have 3 degrees of freedom. So my p-value, I'm going to go ahead and run my chi-squared CDF here with my chi value of 61.27. Come on, this high upper bound. And then degrees of freedom is 3. Alright, and here I got 3.15 times 10 to the negative 13, which essentially, folks, is 0. Alright, so hopefully that matches up what you're coming out with. If it looks like mine, the calculator will give you this little e. This means times 10 to the. And by the way, scientific notation means this is 13 decimal places this way. So 0.1200315, which is essentially nada. So in our conclude, we would conclude that since our p-value is less than alpha, 0 is less than 0.05, we reject the null hypothesis. Okay, now in, words, there is sufficient evidence to conclude that there is a difference between the observed and expected number of jurors in each age group. Okay, now a chi-square test, that's really all it can say. Now, the question originally was, does it appear, so does it appear they were selected at random from the adult population? No. The jurors do not appear to have been randomly selected. Okay, now, it's sometimes said that old people are overrepresented on juries. Based on the chi-square test alone, could we conclude that older people are overrepresented here? No. All we can conclude is that the observed numbers do not match up to the expected numbers, that there is a difference. Okay, we would have to run something else in order to come up with the fact that there's more old people than young people, etc., etc. Based on this sample and this test, all we can conclude is that there is a difference. Okay, whew, we did it, folks. So, one thing I wanted to fix here that I realized I'm pretty sure I messed up is over here. I think this is actually our degrees of freedom, and chi-squared is going to be our lower bound. Sorry about that. That was a typo on me writing wrong on my part. So just keep that in mind when you're running this in the calculator. Your chi-squared value, your upper bound, and then your degrees of freedom. And your upper bound just make big, like 1,000. Okay, and that should get you through it. Okay, your homework is to do the book assignment, and then I may have a little M&M activity video that I will be posting for you, and you're welcome to follow along with that as well. Okay, thanks.